Asbestos-containing materials are now known to pose significant potential hazards for people working in and around buildings where such materials are present. This program is aimed at generally explaining the nature of the asbestos problem as it relates to building workers and occupants.
During the last 2 decades, health authorities throughout the Western world have been warning about the cancer and other disease dangers posed by asbestos. In 1978, the federal government's top health authority issued an unprecedented national warning about asbestos dangers. And although the public concern on this issue came to focus largely on school buildings, researchers were finding that airborne asbestos posed a danger in buildings of all types. In the summer of 1984, the U.S. Environmental Protection Agency completed a nationwide study and reported that as many as 700,000 buildings in cities across the country have potentially dangerous asbestos in them.
Many authorities feel that these figures are conservative, and the 700,000 buildings cited by the EPA do not include hundreds of thousands of other commercial, industrial, and governmental building types that were not included in the study. Asbestos ore is dug from open-pit mines much the same as copper or coal, and for the last century the asbestos manufacturing industry has extracted, processed, and distributed hundreds of millions of tons of this material around the world. Vast amounts of asbestos were used to insulate and fireproof the interior of commercial and military ships in the World War II era. This activity eventually led to the deaths of substantial numbers of shipyard workers who had not understood the strange and harmful nature of asbestos.
Asbestos is a mineral, a kind of rock, but a very weird kind of rock, and to understand why, let's look at an ordinary rock. This is your standard rock that you might find laying around outside, and one of its characteristics is that if we take a hammer and we bash this rock up into the smallest particles possible, what we'll end up with is this, your common everyday sand. Well, one of the characteristics of sand is that no matter how much you pound it up and break it down smaller and smaller, each one of the little particles in this dish will always hold a shape similar to this, roundish. And the reason is that the crystalline structure of ordinary rocks always breaks down into relatively round, lumpish crystalline forms similar to this. Asbestos rock, on the other hand, is very different. It's not formed like ordinary rock. Instead, it has veins of tightly packed rock fibers. And when you pulverize asbestos rock, you get this, a fibrous mass. And no matter how much you pulverize this material, it will continue to break down into smaller and ever thinner forms, like this. The elemental differences in shape between the normal lumpish particles of ordinary rock and the long, thin, fibrous particles of asbestos rock is what makes asbestos bizarre among minerals. No other substance will hold this very long, very thin, and very strong shape. Now, many people, when they hear the word fiber, tend to equate that word with something soft like yarn or sewing twine. Well, in fact, the fibers of asbestos aren't soft at all. They have the tensile strength of steel, and they are much more like needles than anything soft like yarn. This tightly sealed bottle holds asbestos-containing material which was recently removed from the ceiling of a New Jersey office building. If I would open the cap on the bottle, submicroscopic fibers would immediately begin floating into the air where I could breathe them. And as we'll see in a moment, these fibers can be very damaging to the interior of the human body. Structurally, asbestos is very much like manila rope. Similar to manila rope, it has very large strands which are intertwined and can then be broken down into smaller strands, which can then be broken down smaller. And with asbestos, you eventually get to a point when the smallest strands you've broken down are invisible to your eye. When we take one of the visible strands in our bottle and magnify it under a scanning electron microscope, you can begin to appreciate the extraordinary dimensions of smallness involved with asbestos. This is a magnification of 240 times, and you can see what look like bundles of fibers and individual fibers of asbestos. When you take one of the smaller fibers you can see in this magnification and blow that one fiber up 6,600 times, this is what you see. What appeared to be a small fiber is not a fiber at all, but another bundle of smaller fibers. And if we again use the scanning electron microscope to magnify one of the individual fibers in this bundle 20,000 times, we see that even that isn't a fiber at all, but an unbelievably tiny bundle of yet smaller fibers. Each of these fibers are about 0.1 micron in diameter, but even this isn't the end. If we use a transmission electron microscope to blow up one of these 0.1 micron diameter fibers, we see that it's composed of what are known as fibrils, the smallest units of asbestos. And you can see fibrils have hollow centers. They're actually shaped like rolled up rugs, which are about 0.02 microns in diameter.
This is a magnification of a typical mix of asbestos, plaster-like materials, and binders used for pipe and boiler insulation. You can see the large bundles of asbestos sticking every which way as they form the material that holds the stuff together. But because organic binders naturally deteriorate and can otherwise be damaged, large numbers of these tiny, invisible fibers can be released into the air spaces of a building and ultimately breathed in by building users. Asbestos in this state is called friable, that is, it's capable of releasing invisible fibers into the air.
Let's take a look at an actual sealing situation. This is the ceiling of an office building. The ceiling is covered with a typical sprayed-on asbestos material, and notice that this ceiling is not visibly damaged. In fact, it looks pretty nice. However, when a scanning electron microscope is used to inspect the surface of this sort of ceiling, this is what you see. At 400 magnification, asbestos ceiling materials begin to show their fibrous, friable nature. At 1000 magnification, you can begin to see the frayed ends of individual bundles of asbestos in the process of breaking down. At 6000 magnification, you can clearly see the tangle of asbestos fibers throughout the ceiling material. The diameter size of most of these fibers is about 0.1 micron, and the mere passage of air currents across such a ceiling surface can cause billions of these fibers to slough off and invisibly contaminate a building. For people who think in terms of meters and inches, something which is 0.1 micron in diameter is just about impossible to envision. 0.1 micron is 1/10 of 1/millionth of a meter. But this incredibly tiny size is ultimately what makes asbestos so dangerous. No other substance, not even fiberglass or rock wool, will break down into fibers of such incredible thinness and strength. This scanning electron microscope photo shows 0.1 micron diameter asbestos fibers collected from the air of a school. To give you a better idea of just how small these are, let's look at human blood cells at the same magnification. Those big round things you see are individual blood cells. Side by side at the same magnification, you can see that blood cells in 0.1 micron diameter asbestos fibers have a size comparison something like a sewing needle and a water balloon. But what does all this mean? Well, let's take a closer look at a human cell. The cover of the September issue of Science 84 magazine has a particularly good illustration of a single cell. The average size of a cell in the human body is somewhere around 10 to 12 microns in diameter. And when you put a 0.1 micron diameter asbestos fiber next to a 10 to 12 micron diameter human cell, this is what it looks like. But how can something this small hurt us? Well, one way asbestos hurts us is by causing cancers in our bodies. After being inhaled, asbestos fibers can ultimately cause cancer in a variety of organs, including the lungs, the stomach, the colon, the heart, the chest cavity, the kidneys, the larynx, and other sites and organs throughout the body. Well, let's think about this a minute. Okay, I breathe in 2 million asbestos fibers into my lungs. but my lungs are like bags and what I breathe inside them is trapped there. How can an asbestos fiber, which is trapped inside my lung, cause a cancer down here or over here or up here? How can an asbestos fiber, which is inside the lung, cause a cancer on the outside surface of the lung or in a distant organ? Are asbestos fibers able to move outside the lung somehow? Can they travel to distant organs? Well, yes, they can, and they do. Autopsy studies done on victims of asbestos disease have found that those cadavers had asbestos fibers lodged in tissues throughout their entire body. There were even asbestos fibers as far away as their brain. Medical research over the last few decades has established that asbestos fibers have the peculiar capacity to migrate or move throughout the body. What happens is this: a 0.1 micron diameter asbestos fiber is as sharp as it is strong. And when it gets inside the lung, it has a natural tendency to insert itself between the cells of the lung wall. And then, propelled by the natural motions of living tissue, it begins to move and migrate through those cells. In this manner, asbestos fibers actually move through the wall of the lung, and they can also move through the wall of veins. And when they enter the bloodstream, they ride this vascular highway to all parts of the body. And in the same manner, they can migrate into the vessels of the lymph system, which is another highway throughout the body. To better appreciate the full biological dangers of asbestos, let's take a closer look at what it looks like when a 0.1 micron diameter asbestos fiber and a single human cell encounter each other. Even without knowing a great deal about cellular mechanics or microbiology, it's pretty easy to imagine the kind of damage this might do. This textbook, Health Hazards of Asbestos Exposure, has a photo of asbestos fibers inside an animal cell, and this gives you a good indication of the real life-size comparison between asbestos fibers and living cells. The dark blob you see at the bottom of your screen is the nucleus of the cell, and the spear-like structures you see above it are 0.1 micron diameter asbestos fibers. The inside of a human cell is a very complicated place which has systems of internal organs much like those of our larger bodies. It's a place of critically balanced electrical, chemical, and mechanical processes which maintain our normal life functions. We know that when an asbestos fiber and a human cell interact like this, something disruptive happens inside the cell. That something could be a chemical, electrical, or mechanical disturbance, or a combination of the three. In any case, medical researchers know it damages the cell in a manner which makes the cell or the cell's offspring ultimately susceptible to the uncontrolled growth we call cancer. And that's why medical and health authorities have become so concerned about asbestos in buildings. Asbestos construction materials inside buildings can routinely release enormous numbers of these fibers into the air to be breathed by building users. And what makes this all the worse is that this kind of contamination is as invisible to the human eye as it can be harmful to the human body. Asbestos is found in thousands of different products and applications inside buildings. This includes schools and other educational institutions, high-rise office complexes, shopping malls, hospitals, industrial plants, government offices, and public facilities, large and small. There is no specific kind of building which contains asbestos. Unfortunately, asbestos was installed in virtually every kind of building. Generally speaking, asbestos is most frequently found in buildings which were constructed between the late 1920s and the early 1970s when the material was banned. However, those aren't hard and fast dates. Some contractors continued to use asbestos materials in buildings after the ban, and many older buildings which date to the turn of the century had asbestos installed in them during later renovations. Let's look at some typical forms of asbestos construction materials found in American buildings. Asbestos was widely used for ceilings. One of the most common forms of general ceiling construction in the post-World War II period was suspended ceilings. For these, Wire lath was strung and then covered with a concrete-like material known as brown coat. This rough textured brown coat was then sprayed or troweled with asbestos, which is represented by the yellow in this illustration. In areas of damage or repairs, the three layers of wire, brown coat, and asbestos surfaces can often be clearly seen in buildings. In other cases, no brown coat was used and the asbestos materials were sprayed directly onto the wire lath. Asbestos coatings were also routinely applied to a variety of precast concrete and concrete slab forms inside schools, offices, industrial complex, and government buildings. This is a very common type of asbestos application. Asbestos plasters were frequently used around air ducts, boilers, and other thermal equipment. Asbestos plasters were also troweled or sprayed over cinder block. Thick layers of sprayed asbestos were widely utilized in old wooden structures undergoing renovation. This type of application can often be found in barns, lofts, factories, warehouses, and other older structures modernized into office, library, store, or classroom space. Acoustical tile containing asbestos was widely installed in schools, churches, hospitals, shopping malls, and office buildings in a variety of forms. Some are glued directly onto solid ceiling surfaces, and others are hung in suspended tracks. Asbestos was used to coat steel beams in buildings of all kinds, and in some cases the beam itself was coated. In other cases, the ceiling area and the beam were both sprayed with asbestos. Bar joist constructions, which are very common throughout industry, were also heavily covered with sprayed asbestos. Steel decking, corrugated and non-corrugated, was coated with sprayed or troweled asbestos, at times as thick as an inch deep. One of the original and most common applications of asbestos in buildings involved the covering of pipes. In fact, there are millions of miles of asbestos-covered pipes in America.
Thick layers of asbestos-containing plasters were used to cover boilers, often over a matrix of chicken wire. Over a period of years, the vibrations of the machinery itself often pulverizes this covering.
Drop ceilings often hide massive amounts of asbestos materials. Prior to 1973, it was common for contractors to finish off a job by spraying the entire superstructure with thick layers of asbestos. Then they installed drop ceilings so the whole mess was out of view.
Asbestos-containing vinyl tiles were widely used to cover floors. The potential for fiber release from this material can only be fully appreciated when samples are magnified by an electron microscope. Here, the friable asbestos binders are visible where the surface of the tile has been abraded by sanding and buffing machines. Asbestos was frequently pressed into transite board materials, which were used to cover wall surfaces. Asbestos board was used to surface over fiberglass insulation in this auditorium. In some regions of America, building codes previously required that hollow doors be stuffed with loose asbestos. Such doors are frequently found in schools and other public structures.
It's rare that you find a single type of asbestos application in a building. Most frequently, multiple applications are the rule, with sprayed beams intermixed with splattered ductwork and utility systems and asbestos-covered pipes. Some utility spaces are virtual jungles of asbestos-covered forms.
Obviously, persons who must be most concerned about protecting themselves from asbestos are those most likely to be exposed to the hazardous substance. Because of their daily direct contact with structural elements in building systems likely to contain asbestos, certain categories of jobs generally involve higher asbestos-related risks. These include building superintendents who spend significant amounts of time around asbestos materials of all types, custodians who must routinely work around and clean up the debris of deteriorating asbestos-containing materials, industrial maintenance personnel charged with the upkeep of various kinds of utility systems and machinery insulated with asbestos, electricians who install and repair equipment in areas where asbestos is present, Line installers who confront asbestos in many of the spaces where telephone, computer, and other types of communication cables are strung. Carpenters, plumbers, sheet metal craftsmen, HVAC workers, and other construction trades which repair and renovate internal building structures and systems. Recent medical surveys indicate that nationally, these groups of building workers are already experiencing much higher levels of asbestos-related lung damage and disease than other groups of workers. Anyone who smokes also faces higher asbestos risks. In the human body, the residual toxins of cigarette smoke interact with asbestos fibers in a synergistic way. This means that the two substances work together chemically in some manner that increases the cancer-causing effects of the asbestos fibers. In fact, persons who are exposed to asbestos and who also smoke have a substantially higher risk of developing asbestos-related cancers than persons who are exposed to asbestos and don't smoke at all. Anyone who works around asbestos-containing construction materials should understand how to protect themselves from this airborne hazard. For instance, they should have a thorough knowledge of how to select, fit, use, and maintain respirators, which can stop microscopically tiny airborne fibers from getting into their lungs. They should also understand the general concepts of preventing the spread of asbestos contamination throughout the building spaces where they are working. Asbestos is not a reason for panic. The mere presence of asbestos-containing materials in a building does not necessarily present an immediate hazard. Only friable materials which are damaged or deteriorating and releasing airborne fibers are an immediate hazard. Remember, asbestos is a problem, but it can be managed. Two of the most important tools you bring to your asbestos safety program are practical knowledge and common sense. The more you know about asbestos safety, the more you will be able to effectively protect yourself as well as other persons in the building from this serious potential health hazard.